We'll move on to example 4, still on similarity. Example 4 contains question A and question B. In A, let's take A first. In A part, we are told that Mary says 2 sizes of photo. These photos are mathematically similar. The smaller photo has length 15 and width. So let's give a kind of pictorial aid. The first photo is 15 by 12. And the larger photo, okay, the smaller photo is this. His own area, we don't know. And the larger photo, the area we know it, but we have to find his own length. So his own length is what we want to find, but we are giving his own areas as 352.8. So if you look at the two of them, what you do is that since we are finding the length of this, you take length of the smaller ratio length of the bigger, which is 15 ratio L. So we want to equate it to ratio of their area. But the area of the smaller is A equals to length, which is 15, times breadth, which is 12. And that A becomes, if you do 15 times 12, 15 times 12 should give us 180 centimeter squared. Meaning that if the length of the smaller ratio the length of the bigger will be equal to area of the smaller, which is 180 ratio 352.8. But I told us in example 1 that the unit for the area is centimeter square, but the unit for the length is just centimeter. To confirm them, we need to do something like centimeter times centimeter, which will take the form of squaring the two of these to confirm their units. So this one, you put square on the ratio of the, because a side is linear, while the power on area, centimeter square, is quadratic in nature. So you square this one to confirm them. And this should give you 15 square is 225 over L square equals to 180 over 352. So from here we cross multiply. L square will multiply 180 and you have, we have 180 L squared equals to 225 multiplying 3.8 multiplying 352.8. If we further simplify this, we are going to get 180 S squared equals to 225 times 352.8 should give us 79380. So we remove this coefficient first before we remove power. So to remove this coefficient, divide both sides by it. And we have L squared equals to 79380. The coefficient is 180 divided by 180. So divided by 180, that should give us 441. And hence, for you to remove this square, you introduce the inverse, the opposite of square, which is square root. If you take square root of both sides, this square and square root will cancel on the left. You have L left equals to, you have your square root here, 441. So L, which is the length of the larger photo, will be square root of 441, which will give us 21 centimeters. And that's the length of the larger photo. So let's quickly look at what B demands. In B, if you look at it, we have the ratio of the surface area of two similar cylinders is this. Of course, you don't need to, we are not giving height, we are not giving radius. So there's no way you can say, okay, let me equate the value of the area. And of course, this 9 was not the original value of the area, that's the surface area of the cylinder. So because the original value of the area has been simplified, this is a ratio, it must have been simplified to the least form. Maybe the original value was 90 and the second one was 160. If you have expressed it in the least form, you know, that means we have removed factor 10 from each of them to give this. That means we don't even know the original value in the first place. So when you have this and you hear that the examiners talk about the word similar, so please don't stress yourself, just take the idea of similar. They said find the ratio of their volumes. But we can take ratio of their size, any size, maybe height, their corresponding height or their corresponding radii. Let's take the ratio of their radii. The radius of the smaller one ratio the radius of the bigger one equals to the surface area of the smaller ratio surface area of the bigger. But I told us since this one is area, it will be in centimeter square, and this is radius to be in centimeter. To confirm, then you put square on each of these. So this one will now give us R over big R. You can factor out that square for them, equals to the ratio of the two areas given as 9:16. So from here, to make R ratio bigger R, the subject, we can take square root of both sides to remove this. So we now have R ratio bigger R becomes square root of 9/16. 9/16. And that means the ratio of the radii in the first place is 3:4. 3:4. If the ratio of their radii is 3:4, and you ask to find the ratio of their volume, this. So it will just be ratio of their volume, volume of the smaller ratio volume of the bigger, equals to ratio of their side, any linear side, maybe radius, or if you the ratio of their height too, since height too is linear, will still be 3:4. You know, ratio of their corresponding sides will be constant for two similar objects. So this one now, it will be R ratio bigger R. But since R is in centimeter and this one is in centimeter cube, so try and normalize and put cube on each. So that will now mean ratio of their volume becomes the smaller R, that is, you can say 3/4 cube, which will give us 3 cube is 3 times 3 times 3, which will give us 27 ratio 4 cube, 4 times 4 times 4, that is 64. This implies that the ratio of their volume, ratio of volumes is ratio of volumes becomes 27:64 of the two cylinders. So from here, we move on to example 5.